So this video is going to pick up with example 6 here, which you've hopefully already tried, so I'm going to kind of rattle this one off kind of quick here. If you recall, in example 5, we used FOIL, or distribution, to multiply. So I'm going to be multiplying 3 times 3 to get me 9. That's my first terms. My outside terms would be 3 times negative radical 7, which would be negative 3 radical 7. My inside terms would be plus 3 radical 7. And my last terms would be negative square root of 49 from being able to multiply the 7 with the 7 since both are under a radical, which can then simplify down to just whole number 7. Now the interesting thing that happened with this example is that these like terms actually end up canceling since they have the same value. So I'm left with just 9 minus 7, which would result in just the integer 2, just the whole number 2. The reason that happens is because of what structure we have here. We have the exact same terms, the only difference being that there's addition in one and subtraction in the other. When that happens, these are called conjugates, and the result will always be just a whole number. It will enable us to be able to get rid of the radical portions if we multiply conjugates by one another. We're going to use that thinking to rationalize these denominators. Since these denominators have expressions that have addition and subtraction in them, we're going to be multiplying by the conjugate of the denominators. So on this one, I'm going to be multiplying by 5 plus radical 3, since this is just the same terms with the sign changed. And on this one, I'm going to be multiplying by the square root of x minus 5. Now remember, whatever I do to the bottom, I have to also do to the top. Now on the numerators here, you're going to be distributing to each of those, whereas on the denominator, since you have binomials multiplied by binomials, you're going to be foiling each of those. All right, so I'm going to start over here with number 7. I'm going to distribute, which would give me 10 plus 2 square root of 3. On the denominator, I'm going to FOIL. So first will give me 25. Outsides would give me 5 radical 3. Insides would give me negative 5 radical 3. And then my lasts would give me radical 3 times radical 3, which would give me negative radical 9. And this would be negative because I've got a negative times a positive. Now this we know is going to simplify down to just whole number 3. These two are going to cancel because this is what happens when we have conjugates, which means in the denominator I'm just going to be left with 25 minus 3, or just 22. Whereas in the numerator I'm going to be left with 10 plus 2 radical 3. And remember, I cannot add those up and combine those because they are not like terms. This one has a radical, this one does not. What I can do, however, is I can do just a little bit more factoring. If there is a common factor of each of these coefficients, these two coefficients here plus your denominator, I can do a little more simplified, I should say. So since they are all divisible by 2, I can divide here and here, both kind of fractions, if you will, by 2. So that would give us 5 plus radical 3 over 11. And again, the reason I can do that is as if I factored out a 2 and then simplified just that factor, just that fraction. So that's what I would be left with here as my final answer. So you want to be careful and keep an eye out for opportunities to simplify just a little bit further. All right, if I go ahead and try number 8 now, I'm going to distribute. So I'll get 3 radical x minus 15. And on the denominator, I'll get the square root of x times the square root of x. Well, that would be the square root of x squared. That means the square root of x squared, that would just end up canceling down to just x. All right, interesting. For my outsides, I'm going to get negative 5 square root of x. Insides, I'm going to get plus 5 square root of x. And then my lasts, I'm going to get negative 25. Just like we anticipated, the two inside terms are going to cancel out. And like I talked through here, this would simplify down to just x, just the variable x. And on the numerator, I still have all of that. And again, I can't simplify that any further. The only reason this one doesn't simplify down to just a whole integer is because I do have that variable here. But we have achieved our goal of rationalizing the denominator since there are no more radicals in our denominators there. So at this point, you should be able to start worksheet 2 in your packets and practice some of these radical kind of problems on your own.